Good morning, everybody. This is a webinar with Pete Alstead, Wxperts Live, or Wxperts. How to embed a file inside your program and utilize it. Apologize for being a few minutes late. It's mainly Wolfgang's fault. But we'll continue on and turn it over to Pete and let him have at it. Thanks a lot, Pete. Go for it.
All right. Good morning, everyone. So what we're talking about today is embedding a hyperfile classic table in your executable, which may not even make a lot of sense at first, but what we had with a particular application recently is the developer was doing, it's a very large application, so what he was doing was PDF help files for different sections of the application, and then we actually linked those PDF files inside the application so folks could see them, you know, pull them up from within the application when they're working in a section. To make things even more complicated, that application supports 6 languages, so we have 6 versions of each of these PDF files. So you know, it didn't take very long until we had a couple hundred PDF help files that we were distributing with the application. So we wanted a little easier way to get those distributed when we did updates, you know, because a lot of times when we did updates, some of the PDFs would be updated as well. We started down the road, we were trying to find something that would work similar to the way the DLLs work in the executable. One of the options when you build the executable is to embed the DLLs, and then when you first run the executable, those DLLs self-extract themselves out. So we thought, well, you know, generally speaking, when they have a feature like that, that feature also exists somewhere in the WX language. So I went down the road of trying to figure out how they were doing it, and could we do that same thing? Well, FExtractResource, if you look at that in the help files, that sounds like exactly what you want until you realize that only exists on the mobile. So that option was out. You can embed images in your executable and then reference them by their name using DLoadImage, and it'll pull them out of the executable. The only problem is that doesn't work with PDFs. It only works with PNG, JPEG, GIF files, those sort of things. Embedding the PDF in the EXE is very easy, and you'll see how we do that today. It was the extracting out that there doesn't seem to be a native function for. So then I actually got desperate enough to start looking at the Windows API for how to extract a resource out of an executable, and, you know, quickly realized that I didn't have the hair to donate to trying to figure out the Windows API calls, because it was going to be 3 or 4 API calls to accomplish it, because you had to get the address and then extract it, and it got pretty ugly quickly. So I decided that wasn't an option, not to mention that generally when you start dealing with making Windows API calls, you also start introducing more opportunities for your application to GPF. But during my search, I bumped into some very interesting information that says that you could actually embed a hyperfile classic file inside your executable, and then the standard H commands will work against that file the same as if it exists on disk. So that kind of led me down the road to what we're going to look at today. What I wound up doing was creating a very simple little hyperfile classic table that has a couple of fields and a binary memo in it. Then I just store the PDF in that binary memo. I embed that hyperfile into my executable. Then when the executable runs, it can access those PDFs via the binary memo that's in that hyperfile table inside the executable, even though the hyperfile table, you don't see it anywhere on disk. So that's the solution. The final thing that we're also going to look at was when we were distributing the physical PDFs, we would use shell execute to display them. That way it was just displaying them with whatever PDF viewer they had installed on their system. The only problem with that is for shell execute to work, the files have to physically exist on disk. Well, with this solution, we've got them embedded in that hyperfile table. There's no point in writing them out to the disk again. So what I did was create my own simple little, call it a native PDF viewer, so that I could view them directly out of the binary memo field without ever writing them to disk. And we'll look at that viewer while we're at it this morning. So let's get started by taking a look at the application, and we'll run the app. And this is a little demo app, and before anyone asks, yes, I will, at the end of this, I will be posting a link up on Google Plus that will give you this entire app file so that you can play with it yourself. So that will be available later today. So this, in my production application, we have this little app, and it's just a helper app that the developer uses to set up the hyperfile table with all the PDF files in it. This particular screen is never shown in the actual production app. This is just to maintain the file, but in this demo app, we're kind of using it for both purposes. As you see, pretty simple. There's add file, which, as you would guess, lets you select one PDF file to incorporate. Add directory, you point to a directory and it sucks in all the PDF files from that directory. The delete button's pretty self-explanatory, and the refresh button just simply steps through all these. That's why I'm storing the location that the file, the PDF, lives on disk, so that the refresh button can go suck a new version into the binary memo. So right before he releases a new version of the executable, he runs the helper app, hits refresh. Any PDF help files that have been updated get updated in the binary memos of the hyperfile classic table, which then gets embedded in the executable. When the executable updates on all the user machines, the help files are coming right along with it. So it's just a much simpler process than trying to keep track of 120 PDFs as part of an update process. And then view is that little native PDF viewer. Nothing fancy. As you see, it's just a little viewer. You can jump through the pages. You can do some zooming. And the only trick of all this is this PDF viewer is not looking at this physical PDF file. It is looking at that binary memo. So that's the reason that the file, once it's in the binary memo, it doesn't have to exist on the disk on the production machine. So that's how it works. Let's actually take a look at from a technical side. So cancel. We'll go into the dictionary first. One table, pretty simple table. It's got an auto-inc user ID, which all your tables should have. You know, you've been listening to me and Andy harp about that for years, so hopefully every table you have has an AutoInk ID. In my particular instance, I have file name and directory as two separate fields. Depending on what you're using this for, you may want to store it all as one. In the production application where we're using this technique, we're referencing the files by their name because we have a special naming convention that lets me select the languages as part of the naming process. So I need the file name as a separate field, and as you see, that's actually our unique key to the file as well. And then the only other piece of information in this file is the actual binary memo that we're storing the PDF into. So pretty simple file. And again, this is a Hyperfile Classic file. All right. If we come over to the project code, this is where the magic happens. If you look at the help for WINDEV, and I know you read the help for WINDEV, you'll find that by default, when you reference a Hyperfile Classic table, it first looks for it to be embedded in the executable or WDL, and then it falls over and looks for it on disk. So that's actually the default behavior for Hyperfile Classic files. So technically, I wouldn't even need this code, but this is a pretty advanced technique. So to save the sanity of the guy that has to come along behind me and figure out what the heck I'm doing, I actually put these statements in to make it a little more obvious what I'm doing. So if I'm in test mode, which means I ran it via the Go button, then it is reading that PDF file from disk. That's what the HDisk constant does. Otherwise, which means I'm running it as a standalone executable, it looks for it embedded first, and then it will fall over to disk even with this option. Again, this is actually the default option. So that is one thing to keep in mind when you're doing your testing and so forth, is you need to verify that you really are getting the behavior you want and you're reading the file out of the embedded EXE, not reading the file off disk. And we'll actually look at how we do that shortly when we actually take a look at the program. So that's the only code on the project side. Next, let's look at how we add those files, the PDFs, to the Hyperfile table. And we'll look at the add directory code, because the add file code is just a simpler version of the add directory code without stepping through all the files in a directory. And it's pretty simple. I turn on the hourglass. Is that resolution big enough, Andy? Okay. Andy dozed off, so we'll assume it is.
No, I turned off my mic and I was sitting there talking. Yeah, it looks fine.
All right.
You just share to everyone so that way it doesn't switch over when I talk. There you go.
I haven't. No, I don't have any.
Okay.
I'm just sharing. So anyway,
right,
I turn the hourglass on, and then I'm using FSelectDir, which is a standard WINDEV function that calls the window picker in directory mode. So that lets you select a directory. If they selected a directory, because you can cancel out of that screen. So if it doesn't return a directory, I know they cancel out of that screen, and I just drop out of all this code. So if they returned a directory, then I use another function, flistFile, which that lists all of the, and in this instance I'm saying give me all the PDF files in that directory. And what that's returning to me is a character separated string of file names. And there's a lot of different options and so forth that you can use with this function to how you get that list back. For me, all I wanted was full path, file name, character separated, which is this format of the call. So if there are any PDFs in that directory, then I fall into this for each loop. There are a lot of different for loops in the WX language. If you haven't seen this particular one, take some time to read the online help, because it's a pretty powerful and useful one in a lot of instances. And what this is doing is I'm saying for each string, and then what it's doing is putting each instance into this temp full file name string variable of that character separated list, and I'm saying that it's separated by the carriage return. So what it's doing is looping through that string of carriage return separated values and giving me one instance at a time in temp full name. Now, if somebody were to send me a list that's semicolon separated, or one of the ones that you run into often, especially in the mainframe world, is pipe separated list. The only thing you have to do is change that right here. So again, very powerful, handy function. So then for every full name I get, all I'm doing here is using some handy WINDEV string functions to break it out into full path and file name. Then I simply am doing an hread-seek on the file name to see if that file has already been included in our list. If it is, I'm just updating it. Otherwise, I'm adding it. And the only lines that really mean anything that we aren't standard is this line right here, and its equivalent on the add side right here. That line is using load buffer to load that physical file off of the disk into our binary memo. So that is how we're getting that PDF from the disk and storing it in our binary memo field, is with fload buffer. Once it's all done, we just refresh our table in case they've added files, they get redisplayed, send a little message letting them know we're done, and shut off the hourglass. And like I said, the add file is just a smaller version of that same code that's only doing one file. So no reason for us to step through that code. All right, so now at this point, we have our Hyperfile Classic table populated. Because of being able to use these two buttons, it's populated. That binary memo is loaded up with them. The only trick left is we need to embed those files into our executable when we make our executable. There's a lot of different ways to do this via the IDE, I'm sure. Because I always have this Project Explorer open, I tend to use it more than some of the other methods. And from the Project Explorer, all you have to do is you come down to Other, which is one of the folders shown in the Project Explorer, and right-click and choose Adding Elements. And anything that you add to this list will get embedded into your executable as a resource. And in this case, we need to do the FIC file, which is the actual file. the MMO file, which is the binary memo, and the NDX file, which is the index. So we need to include all three of those files into our executable. So at that point now, once we've said we want those files included in our executable, then we can make our executable and they'll get embedded. So we come over and we generate our executable. I'm sure at this point you probably have generated some WINDEV executables, so we're only going to touch on a few settings on these screens. Notice on this implementing the library, those three files that we added to the other folder are listed here as being included in the library. There's actually an add button here, so this is yet another place where we could have added them to the list to be embedded in the executable. For this demonstration, to make it a little simpler, I'm including telling it that the data file exists in the same directory as the executable. I also have UAC shut off on my development machine because otherwise it just drives you nuts. This setting gets a little tricky with UAC because Windows doesn't want you updating files in the executable directory. They want you storing them in the user directory and all that nastiness, but doesn't affect us in this instance since I've got UAC shut off. Then I am including the DLLs into the EXE. Used to, there was the option would extract the DLLs at startup. Apparently with 20, they've decided that they don't want to do that. It's still supported because Windows is very good at always supporting stuff that they used to do. But now it seems like the two options they want you to use, and I'm sure this has to do with UAC issues that they kept running into. So now the options that they tend to want you to use is either separate DLLs along with the EXE or just embed the DLLs in the EXE. The obvious difference between these two is the size of your executable. If your project has multiple executables, you might be better off doing the DLLs separate. That way they could be shared between the EXEs. It also makes it a little cleaner and quicker to do updates if you're only updating EXE. The downside for me with that option is when I update WINDEV from version 20 to 21 here in a few weeks, I would have to distribute 21 DLLs and get rid of those 20 DLLs. Since I build it with the DLLs included in the executable, I don't have to deal with that. Because when I replace that EXE, the DLLs go with it. So I take the hit of having bigger EXEs to make my release cycle a little simpler. This stuff doesn't matter. That's all UAC manifest. That won't affect us today. So at this point, we've created an EXE. And those files are actually in that EXE. Now, we can see that in action, and I have copied that EXE over to my temp directory. If I can just find my temp directory. There we go. And if we run this, we see that we're still seeing the list of files. And if we click view, they're coming up to be viewed. Now, if you're not 100% trusting that that really is using that hyperfile from the embedded hyperfile and viewing the PDF out of that hyperfile, you could actually come over to the project, because all that stuff exists in this EXE directory right here. I could rename this EXE directory where it wouldn't be able to find any of it. Can't, because it's being used, but you could delete those files, move them, whatever, and this application would still work. Now, another way that you can tell is when you embed your hyperfile in the executable, it is in read-only mode. You can't update that hyperfile table, which, if you think about it, makes a lot of sense, because it would be a crazy, insane world if you were trying to write new data into an embedded hyperfile into your executable while you're running that executable. That would be a recipe for a pretty immediate GPF. So instead, the files are in read-only mode. So if we try to add a file, we'll get an error. And if we look at that error, it's telling us exactly what I just told you. The files in the libraries cannot be opened in write mode. So that's another way that we now know it is absolutely reading that EXE file from, or that hyperfile from the embedded hyperfile, not getting anything off disk. So the only thing that exists, the only thing I have to give you to run this and look at those PDF files is this executable file. You don't need anything else. So that is all there is to embedding the hyperfile table in your executable and using that technique that I've been talking about. So, you know, I could end the webinar right there, but, you know, I like to give you a little bit of bonus material. So we're going to take a look at the PDF viewer side of things now. Like I said, in the original production app, we were using shell execute, but that requires the files to physically exist. So I had to come up with another solution. So I created my own little PDF viewer. If we look at the code behind the view button, it's pretty simple and straightforward. If you've got a record selected from the table, I get that record, and then I call my viewer window, passing that binary memo as a parameter to the viewer. So now we'll actually take a look at the viewer window. And the viewer window is a pretty simple window. It's got a toolbar with a few useful buttons on it and an image control. That image control is set up to be homothetic without enlargement. In other words, I don't want it to stretch an image out of shape. I want it to display it in its natural size, you know, ratios. And then I've also got the anchoring set to stretch width and height. So when the window resizes, the image resizes with the window. Then if we look at the code, again, that memo field is coming in as a parameter. All I'm doing is setting that image control to that binary memo. That automatically displays that PDF in the image control, because WINDEV image controls natively support displaying PDFs. Then I'm setting the zoom level to adapt to width, which means that it's going to fit widthwise and if it's taller than a page, we won't see the whole page, but we will see the whole width. This init title bar and page number procedure. We'll take a look at that code. It's pretty simple code. It's setting the caption of the window to tell us what page we're on and how many total pages there are. And then this code here is some pretty simple code that's enabling or disabling the page up and page down buttons based on what page number we're on. The reason this is in a procedure is because we're calling it from several of those buttons up on the toolbar. We don't want to repeat that code, so it's stuck in a procedure. All right, so now let's take a look at the code behind some of the buttons. And if you were expecting some complicated PDF image manipulation code, you haven't been paying any attention to me ranting and raving about how great, wonderful, and easy WINDEV makes my life, because there is no complicated code to this. Here's our page up button, our page down button, and then the page number is actually an edit control, so you can actually directly type in a page number as well. If you look at all three of these, the only thing they're doing is changing the page number property of the image control and then calling our procedure, which changes the caption and enables or disables the buttons. So the only thing I need to do to move from page to page is change the page number property. Can't get a whole lot easier than that. So at least there must be some complicated code behind all the zoom buttons, right? Wrong. Again, if you've been paying attention, WINDEV makes your life easy. If it's hard, you're probably doing it wrong. WINDEV just makes so many things easy. So here is all of our zoom buttons. Zooming in and out, fitting to the screen, fitting to the width, fitting to the height. And again, if you notice, all of these functions, all they're doing is changing the value that's stored in Zoom. You can either give it an actual value, which is a percentage, or you have three constants for adapt to size, adapt to width, adapt to height. And that's all there is for all those zoom buttons. That is the entirety of the code for the little PDF viewer window. So again, nothing fancy, but definitely very handy. Hopefully this thing has inspired you some ways that you might could use embedded hyperfile classic tables in your own projects. A couple, along with distributing these PDF help files that I'm doing, a couple of the thoughts that have come to my mind is, you could maybe you have some image files that you're distributing that you don't want to have out on the disk and physically accessible. You could embed them like this and use them like that. Now, do understand that anyone that really knows their way around Windows can probably extract those out of the executable anyway, but if that hyperfile classic table, if you've got them in that, and that hyperfile classic table is encrypted, you're making it pretty tough on them. Another thought that I think this would be really handy for is if you had an electronic catalog of products, you could create a catalog as a single EXE file, even if it takes multiple hyperfile classic tables to actually build your catalog, product header, product details, some pictures, who knows how many different tables you might have involved in actually displaying your catalog. You could embed all those tables in your EXE and distribute your catalog program as a single executable file. So that would be something that's very handy for. I also think that that there's probably some uses for this for some type of high-end licensing, where it's an application that you only have a few copies out there in the wild, where you could actually embed that hyperfile license record into the executable as part of the build process, and build individual executables for your client. So that might be some type of high-end licensing that you're doing for a particular application. So there's, I think, a lot of things you could do with this technique. I'm sure there's some guys on this webinar that are way more imaginative than me. Will come up with even better ways to use this. Just be sure to come back over to the Google Plus group and tell us how you are using it, and let us share it back for us, so that we all can learn from that experience. As I said, this entire project I'm going to be posting here shortly over on the Google Plus group. I'll post a download link so that you can go download the project and play with it. And that's it for me. Anyone got any questions or anything, Andy?
I'm not seeing any questions right at the moment. Not seeing anything at all. We'll give them a moment or two. In 2 weeks, we'll be finishing up the part 3 of my series on web services and mobile. We'll actually be putting the mobile to work in the web service to work inside of a mobile device, and executing that, and giving you some tools to actually test mobile without ever picking up an actual Samsung or something device. So there's some tools out there I found that you can actually show what's happening on the actual mobile device running an Android APK on your PC. So I'm going to be showing that as we go along as well. I still don't see any questions. If anybody has any topics and stuff they would like to explore, if you have a topic that you have been doing and would like to explore it, I know there's some people out here who have been around WINDEV for many, many years that probably know some tips and tricks that we certainly haven't found in the last few years that we've been using them, but would be more than happy to put you on the bubble here and let you do it. We're not proud. We ain't got to do every one of them. We really don't want to. We'd rather you guys also contribute. So we appreciate everything's going. Other than that, here's a bit of wonder here. I got here so late, so wonder when the videos get started converting, Diego, right after I do the stop broadcast. It starts publishing then. It probably, I'd say about 10-15 minutes is, and then it takes a little bit of time and eventually gets clearer and clearer, but usually about 10-15 minutes, and it's out there on YouTube, ready to go. Pete's already shared the post of different things out there. I think it was you posting the zip file.
Yeah, I'm doing it right now. So just shortly, all that'll be over on Google.
So you'll have the actual application and everything as well, ready to go. Other than that, I'm not seeing anything else, guys, unless somebody's got another question. And all I can say is y'all be good or be good at it. Appreciate your time this morning. Have a great Friday. Enjoy.
Have fun. Cheers, guys.
Cheers. See ya.